Hmm. Thank you. Okay. Sorry for your disturbance. So here, Tarini, if you see, they are saying that is what the rule is there. If so many ions are there, the less reactive element will usually be formed. Which one? The less reactive. Up now, you are saying that is K plus is there and H plus is there. Now you need to see which one is less reactive out of H plus and K plus that is going to form. Up now, if you know last class I told you reactivity series like that top one is there, K is there, Na is there, Mg is there, Al is there, okay, Zn is there, Fe is there, then hydrogen is there. So they are saying which one is going to form. This is the decreasing order of reactivity. Decreasing. Okay, decreasing order. And below it will coming Cu, Ag, Au. These are there. So decreasing order there. So they are saying the less reactive element will usually be formed. So if I will ask you, Tarni, out of you go which one? Out of potassium ion and that is a hydrogen ion. Which one is more reactive, Tarni?
Potassium.
No. See, again you read decreasing order of reactivity. Tell me, decreasing order of reactivity. When you this is going down, means the decreasing. It is the reactivity order is decreasing. Can't
Yeah.
you understand? So which one will be
More
the least?
reactive is potassium and least reactive is nitrogen.
Okay. So according to rule, which one will form the compound? Potassium or hydrogen? Read this one.
The less reactive metal will usually be formed.
That is which one is less reactive?
Hydrogen.
Hydrogen. Now see here. H plus ion formed for H2O are discharged at the negative electrode, that is H2 gas. K ion stay in the solution. So are you be able to understand this one? If so many ions are there, so which one is going to discharge? Which is having less reactive. So that is hydrogen. In solution, you will usually have positive charged metal ion and H plus ion attract to the cathode negative electrode. Look in the figure. It shows that what happened in electrolysis of the solution of potassium compound, hydrogen is less reactive than potassium. So hydrogen is produced at the cathode rather than the potassium. Okay. Can you understand this one, Tarini?
Yes.
Okay. So Tarini, if I am giving you, I am having Na plus, then I am having K plus, okay, and then I am having Al3 plus. So which one is going to discharge as cathode? Can you tell me? Can you guess? Out of sodium, potassium, and aluminum, which ion will discharge at cathode? Yes,
Um,
Tarni. Hmm. See the table.
Aluminium.
Aluminum. Very good. So what happened at a node in the electrolysis of aqueous solution? Hydroxide ion, OH ion from the water are often discharged. Where? That is they are talking about now a node. Okay, not cathode. So that is negative ion water often discharged. When hydroxide ion discharge, you see oxygen gas given off at the anode. So what is happening? 4 OH are there. So that is it is forming 2 H2O O2 plus 4 electron is out. So loss of electron is at the oxidation and taking place at the anode. This happen unless the solution contain a reasonably high concentration of halide ion, that is group 7 ion, such as Cl minus ion. In this case, the halide ion discharge and the halogen is formed. So 2Cl minus ion giving Cl2 plus 2 electron. 2Cl minus ion, what is going to give Cl2 and 2 electrons? So loss of electron is going to happen. Where is happening? This is also going to happen at anode. So the order of discharge is starting with the easiest at the anode, the halide ion, hydroxide ion, all other negative charge at anode. Can you understand this one?
Yes.
Okay, thank you. Now let us key point firstly. In electrolysis, the ion move towards the opposite charge electrodes. That is okay. So, Tarni, positive ion will move towards the cathode or anode. Positive ion, where it will move
Positive ion will move.
towards. They are saying oppositely charged electrode.
Yeah, so positive will move towards the negative, which is the cathode.
Very good, very good. You are great. Okay, second. At the electrode, negative ion are oxidized at the anode, while positive ion are reduced at the cathode. That is very easy. When electrolysis happen in the aqueous solution, the less reactive element, either hydrogen or the metal, is usually produced at the cathode. At the anode, you often get oxygen gas given off from the discharged hydroxide ion produced from the hot water. That is very easy. Can you read this question number one? Can you?
How do negatively charged ion become neutral atoms in electrolysis? They
Hmm.
so because they're negatively charged, they're attracted to the anode, which is positively charged, um,
Hmm.
and they gain electrons,
Hmm.
which makes them stable or
Hmm.
their structure of an
Okay. Hmm. Hmm.
atom.
Okay. 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 So negative charge ion, just now we studied, that is OH minus ion are there. We are taking 4 OH minus ion. So 4 electron is going to be out. Then what is forming? 2H2O plus what is O2. You can count. Hydrogen are 4, oxygen are 4. Okay. Negative charge are how much are there? Electron are also going to be 4. So this is how do negatively charged ion become neutral atoms in electrolysis? By the loss of electron. In this reaction, oxidation of the negatively charged ion takes place. That is okay. So is this reduction or oxidation? So you tell me what is
Oxidation.
oxidation. Thank you very much. B number question. Can you read B number?
How do positively charged ions
Hmm.
become neutral atoms in electrolysis? Reduction takes place, positive moves to negative.
Hmm. So how do positive charge ion becomes neutral atom in electrolysis? Okay, how do positive charged ion becomes neutral atom in electrolysis? By, you are saying by reduction, yes or no?
Yes,
So suppose 2H plus are there, plus you are adding 2 electrons, so it become H2 neutral. Is this reduction or oxidation?
reduction.
Reduction, thank you. Question number 2. Can you read the question number 2,
What is
please?
formed at each electrode
Hmm.
um, in the electrolysis of
Okay.
molten lithium oxide?
Hmm.
So lithium would be at the cathode
Hmm. Hey, Asa, getting disturbed, yaar.
and oxide would be at the anode.
Very good, very good. So they are saying if you are having the molten lithium oxide, so Li2, so what it is giving 2Li plus O2 minus. This is there. Now,
Yes,
so it is going to discharge at where? At
cathode.
cathode. Cathode. So it will convert get so 2Li plus it will get the 2 electron. So it will again be 2Li only, but charge will be. Now O2 here is the we are having this ion is there. What is this ion? That is O2 minus. So take two molecule. So it is going to be O2 plus 4 electron will be out. So this is very easy. Lithium oxide. Copper chloride solution. Suppose you are having Cu2Cl2. This I am taking. So it is giving 2Cu plus and C2Cl minus. So Cu plus, it is going to be discharged at cathode. and Cl minus, it is going to oxidize at anode. So it will form that is Cl2 and it will reduce into 2Co. So it is simple. Sodium sulfate. If you're talking about sodium sulfate, so here I am a Na2SO4. So Na2SO4, Tarini, if you are talking about, it will give 2Na plus SO4 2 minus. So Na2, it will take the 2 electron. Okay. So it will convert into 2Na. Where it is happening? It is happening, going to be happen at the cathode. This is what. Now sulfate ion is there at anode. SO4 2 minus is there. So it is going to form SO2 plus O2, plus it is going to be 2 electron, it is also. So it is happening at anode, and it is what is at cathode. This is what at cathode. This I wrote here. Can you understand this one?
Yes.
Okay. I think you are getting bored or what?
No, sir.
Hmm. Okay, question number 3. Tell me. Copy and balance the following half equation where it is necessary. So you already last class, I think you told. So here will be 2 and this will be 2 electron. Here will be 2 electron. Here will be 2 electron. Okay, that is okay. Here will be 3 electron. Okay. This is correct already. H plus 2 electron, correct. Here will be what? 2 electron. No, 4 electron, 4. Here will be OH. So it you take 4 electron. Here is nothing. 2 and 4 electron. So this is like that. You can easily do. Extraction of metal, Tarini. This is what? What do you mean by extraction of metal, Tarini?
Its attraction of metal is finding pure metal
Hmm.
from a compound.
Hmm. Hmm. Very good, very good. Metals are actually present in the earth crust. Okay, earth. So they are extraction from there and being used. That is all the process is called extraction. Okay. You already know that aluminum is very important metal. The use of metal or its alloy include pens, overhead power cable, aeroplane, cooking foil, drink cans, window and no patio door farmers, bicycle frame and car bodies. So these are there. So firstly, see how aluminum are being extracted here. You can see. See, this is the ore, bauxite ore. You know, this is the bauxite ore are there present in the earth crust. Where it is present? Present in earth crust. Present in earth crust.
Yes, yes.
Now, what you are doing, you are purifying this one ore. That is whatever the here you can see color here. Here is the clay is there, clay. So you are removing, then it convert after purifying, it is converting into getting aluminum oxide. Okay, we are heating this one after purifying, it is converting aluminum oxide. Then we did the electrolysis and it become the aluminum metal. So see the color, you can see color and shape, you can see. Now let us, we are trying to read out. Okay, you please, Tarni, you read now. You when you read, it become very nice, very easy for me. Hmm.
Okay. Aluminium is quite a reactive metal.
Hmm.
It is less reactive than magnesium, but more sorry, but more reactive than zinc or iron. Carbon
Hmm.
is not reactive enough to use in its attraction, so you must use electrolysis. The compound electrolyzed is aluminium oxide, Al2O3.
Hmm.
Aluminium oxide is extracted from the ore called bauxite.
Bauxite.
Bauxite. The
Hmm.
ore is mined by open cast mining. Bauxite contains mainly aluminium oxide, however, it is mixed with other rocky impurities.
Hmm.
So the first step is to separate aluminium oxide from the ore. The
Hmm.
impurities contain a lot of iron 3 oxide. The color of the colors this
Hmm.
colors the
Hmm.
waste solution from the separation process is rusty brown. The brown
Hmm.
wastewater has to be stored in large lagoons.
Hmm. What is lagoons, Tarni?
It's just like a container.
Okay, very good. So you easily you can understand what they are saying. Aluminum is quite reactive metal. Okay, reactive than what they are saying, but
Nickel.
it is less reactive than magnesium, but more reactive than the zinc or iron. So you can see the reactivity series also more than magnesium is there here. I don't know more than no, it is more reactive than less reactive than magnesium and more reactive than zinc and iron. Okay, so you can see aluminum is below the magnesium, so less reactive, but above zinc and iron, so more reactive. That is what the point they are mentioning here. Less reactive than magnesium, but more reactive than zinc and iron. Carbon is not reactive enough to use extraction, so you must use electrolysis. The compound electrolyzes aluminum oxide. Okay, so how we are aluminum oxide, if you are electrolyzing, how the product is going to be formed? Here you I am writing. So Al2O3 are there, you are electrolyzed to 2Al3 plus is there, plus 3O2 minus, right? So 2Al3 plus is there, you can add 3 electron, so it become the aluminum metal, and 3O2 minus is there. Okay, so it is going to be Tarni, that is, how can you take, you can take it is little bit, we need to balance this equation because it is not balanced at all, so it can create the problem for you. So let us balance in different format. How I am balancing, that is 2 I am taking, so it is 2, and here is the 6O minus. Okay, that's what. Now 2Al3 plus is there, so you can add, that is 3 2 ja 6 electron, so it will become the 2Al. Okay, that is what is called reduction. This is what is reduction. Second one, you
So can
see.
you repeat again from like how did you get the equation?
Okay. 3O2, okay, it will be 6 electron. Just for balancing now, if suppose 3 oxygen are there, 3 O minus, so how many you, how we can write O2? We cannot write now. O2 exists like this one because 3 oxygen here, 2 oxygen.
Yeah,
So
so
what I
it's
simply did, I can convert into the even number. So how I convert into even number? By multiplying by 2. 2 if you are multiplying, so it will be 6 oxygen. So 2Al is there, 6 electrons. So Al become 6O2 minus are there, 3O2 and 6 electrons. So this is what the answer. Can you understand this one?
yes. So is that bauxite?
This is the bauxite only. Or you, it is also called aluminum oxide. Aluminum oxide.
Okay.
Hmm. That is also called ore. Ore means what? The mineral containing more amount of the metal. Now, I'm going the here. Aluminum oxide extracted from the ore called bauxite. The ore is mined by open cast mining. Open cast mining means then the no mines are there, na? Many mines are there. That is open you from the earth we are digging and taking out. Bauxite contain mainly aluminum oxide. However, it is mixed with other rocky impurities. So it may be the rock in the aluminum oxide. So the first step is separate aluminum oxide from ore. These impurities contain a lot of irons, third oxide. This color the waste solution separated, that you already know, that we can color convert into the taken into lagoon. Electrolysis of aluminum oxide. You can see here they mention here two molecule of Al2O3 they have taken, so they are getting 4Al and 3O2. That is what I explain here. You can see 2Al2O3 they are there, so they are getting 2Al, right? And how much? 3O2. So here you see the same 3O2, 4Al. Okay. Acha. Here the oxidation Al is there, 3 electron added. So he is become Al, 2O2 are there, so O2. Okay, these things are there. So easily you can understand here. I am reading. The to electrolysis the aluminum oxide, it must be first melt. This enables the ion to move to the electrode. Unfortunately, aluminum oxide has very high melting point, 2050 degrees Celsius. However, chemists have found a way of saving at least some energy. This is done by mixing the aluminum oxide with molten cryolite. Cryolite is another ionic compound. The molten mixture can be electrolyzed at about 850 degrees Celsius. The electrical energy transfer to the electrolysis cells keeps the mixture molten. The overall reaction in the electrolysis cell is what? Aluminum oxide are there, it is converting into aluminum and oxygen. At cathode, negative electrode, each aluminum ion Al3 plus gain 3 electron. Okay, so each aluminum it is giving it 3 electron, to 2 aluminum will get how many electron? 2 Al 3 plus is there, how many electron required? 6 electron. So it will give convert into 2 Al. Are you getting this one?
A little bit, yeah.
See, one aluminum is there, so 3 electron because 3 positive charge are there. So if you are taking 2 mole, so 3 2 just 6, 6 electron required, na? 6 positive means 6 negative electron required. Yes or no?
Yes.
Hmm. The aluminum metal form in molten at the temperature of the cell and collected at the bottom. So here you see in the diagram, where is the diagram here? Here is the molten aluminum you can get. This one molten aluminum is trapped here. Okay, next point you see. At anode, what is happening? Each oxide ion O2 minus loses 2 electron. The ion turn into oxygen atom. We say that O2 minus ion is oxidized as the loss of electron to form oxygen atom. These bond pair molecules form O2 gas. The oxygen react with the not carbon anode, making carbon dioxide. So it is oxygen whatever releasing, that is also going to react with the carbon anode. The oxygen react with the hot carbon anode, hot, not hot carbon, making carbon dioxide. So the carbon anode gradually burned away. This need to be replaced in the cell regularly. Now, firstly, let us recycling is recycling one aluminum can save enough energy to run TV for 3 hours. See the key point: aluminum oxide from the oxide from the ore bauxite is electrolyzed in the manufacture of the aluminum metal. The aluminum oxide is mixed with molten cryolite to lower its melting point. Aluminum form at the cathode, negative electrode, and oxygen form at the anode, positive electrode. The carbon anodes are replaced regularly as they gradually burns away. So where are the carbon electrodes are there? Na? These are, this we have to regularly replaced. Okay, these are the molten aluminum, they are going to be out. So this is what the process all there is, Tarini. Again you read this key point because you may not be able to understand key point. You read and then explain. Tarini,
Okay.
please. Hmm.
Aluminium oxide from the ore bauxite is electrolyzed in the manufacture of aluminium metal.
Hmm.
The aluminium oxide is mixed with molten chrolite to lower
Hmm.
its melting point.
Hmm.
Aluminium
Why cryolite is what, Tarini? Its formula is cryolite NaAlF6. NaAlF6. This is called cryolite. It lower the melting point. It lower the melting point of what? Al2O3. Why we need to lower the melting point? Because its boiling point, melting point, you see, melting point is how much? 2050 degrees Celsius. So 2050 degrees too large temperature, so that cryolite is being used to lower the melting point. Okay, now next point. Hmm.
aluminium
Read it.
forms at negative cathode, negative electrode,
Hmm.
and oxygen forms at the anode, which is the positive electrode.
How can you say that?
Because aluminium needs to aluminium is positively charged, so it goes as
Hmm.
negative.
Hmm.
Oxygen is negatively charged, so it goes as
Hmm.
positive. The carbon
Hmm.
anodes are replaced regularly as they gradually burn away.
Hmm. Hmm. Very good, very good, very good. Okay. Hmm. What else? Now, summary questions. Please read the summary question one by one.
Explain why aluminum oxide must be molten for electric. It must be molten so that the ions are free to move, and electricity is passed when electrons are free to move. So if ions can move, then electricity can be passed through it.
Correct. Next. Why cryolite is used? Molten cryolite.
To reduce the temperature, boiling point of aluminium so that less energy is used.
Okay. Reduce the boiling point or melting point, Tarni?
Melting point, sorry.
Next question number 2.
Why
Why
are
are carbon anode replaced regularly in the industrial electrolysis of aluminum oxide? Why? As they gradually burns away.
away?
Next question number 3A. Question number 3, Tarni.
Write half equations for the change at each electrode in the electrolysis of molten aluminum oxide.
Can you write this one? You write down. Try to write.
Al2O3.
Can you write on the screen? Is it possible?
No.
Not possible.
No.
Okay.
Should I
Then what?
screen?
Screen is here now.
Yeah, but only if I share I can write. That's the thing. That's what I'm saying.
Okay. Can I share the white one? Then you can
Yeah,
write.
if you share the whiteboard, yeah, I can. I think.
Okay. Let me share the white one. Okay. 1 second. Share whiteboard. Yeah. Write down.
Okay.
Your handwriting is very nice, huh?
Yeah, because that was on my old computer. This one is in touchscreen, so I don't know how this will turn out.
Okay, no problem. Write down.
I'll try.
Mhm.
Al2O3,
O3. Mhm.
which was
Mhm.
Al2, I think.
2Al3 plus. No, 2 will be this
In
side.
front.
Hmm.
I can't read it.
2 will be here.
Plus O3.
How many O3? That is the problem now. That you
Yeah,
need to
so
balance.
we'll have O3 here, and we'll have 2 in front.
So O3 is not the oxygen. O3 is ozone. And ozone does not form. This is not the correct one. What is the formula of oxygen is O2? Then what you will do?
Then I'll add 3 in front.
So what you need to do, Tarani, 2Al2O3. So you will forming that is 4Al plus 3O2. Now check. How can you check? AlO. Here you check. AlO, left side and right side. Aluminum is 4. This side 4. Oxygen is how much? 3 2 just 6. Oxygen is 6. So how you will write? This is the balance equation. Can you understand?
Yes.
Okay. Then one more things. Product of what the question was there? Product of electrolysis, na?
No half equations. Yeah.
So so half equation, how can you write? So Al is there, it is removing 3 electrons. So it will forming Al3 plus 3 electron, right? Then
Yes.
if suppose O2 is there, so what it is 2O2 you are taking, so it is forming
So
O2
O2 plus
plus 4 electron.
4 electron minus. Yes.
Okay. Otherwise some other things are also there. How can you write? Suppose you are taking 4Al, 3 plus. Okay. So don't write this one. Anyway, you need to write the balance one. This is the balance one. Okay. Then that you can check in book also. Let me share again the screen. Sorry, wait. 1 second, please. Where is the Zoom gone? Hmm. No bookmark. Is there? Is it visible, Tarni?
No,
Not share, I think.
I didn't share.
Now I think visible. Tarni. So write half equation for the changes at each electrode in the electrolysis, that is over. B number, explain which ion are oxidized and which ion are reduced at the electrolysis in molten oil. Can you tell me aluminum ion and oxide ion, which is oxidizing, which is reducing? Yes, Tarni.
Oxidizing is oil oxidizing
Oxide ion.
oxide.
Negative, and reducing is what? Aluminum ion. Getting? Because positive charge is there, na? Al3
Yes,
plus is there. So it is taking 3 electrons. So it converting Al. So gain of electron is what? Reduction. So it is getting reduced. Explain why the extraction of aluminum required so much energy. Why so much energy required, Tarni?
because it has a really high melting point.
Okay. Good. Very good. Tarni, next one. Explain why aluminum metal was only discovered in the early 18th century, despite it is being most common metallic element in the earth crust. Why, Tarni?
It's because they only now found out how to use it as pure.
Reduced. Why? How to extract? That is what the
Yeah.
problem was there. Okay. So electrolysis of brine. What is the brine, Tarni? Do you know brine? Brine water, brine solution.
No.
Brine solution is salty water. Brine is salty water. NaCl is called brine. NaCl aqueous is called brine. Brine. Okay. So the sodium chloride solution is called brine. So they see the electrolysis of brine. Brine is what? Concentrated sodium chloride solution. Is a very important industrial process. When an electric current is passed through the brine, you get three products. What are there? NaOH, sodium hydroxide, that is alkali. Second one, chlorine gas. And third one is oxygen gas. It is very interesting, hydrogen gas. It is very interesting. You will find very interesting this one. Now, chlorine gas produced at anode, hydrogen gas produced at cathode, sodium hydroxide solution is also formed. You can summarize the electrolysis of brine as. So let me explain you in different way. Okay, where can I explain to you? So what I am doing. Hmm, yeah. Hmm, yes. So here, Tarni, you see, this is what you are having. We are having NaCl. So it is converting what the ion it is going to give, Tarni. NaCl, what ion it will give?
Sodium. Sorry, salt.
Na plus Cl minus ion.
Oh, I
H
thought you
plus
said.
uh,
Um,
OH minus ion. Take. Now this, if you see these things, one positive, one negative, it is already neutralized. So here product I am writing product. See the product. Product Na plus OH minus ion, it is giving NaOH. That is no problem. Now we are having the at anode. At anode. So we are having two options. Anode means oxidation. Oxidation means what, Tarani? Loss or gain of electron.
oxidation is loss.
So which one is going to lose? H plus or Cl minus ion?
H plus.
H plus don't have any electron. So how it can lose the electron?
Sorry, NaCl minus.
Cl, only Cl minus ion are there. Na? Now in
Yeah.
the solution, four type of ion are there. Na and OH already combined here. So what is we are having Cl minus or H plus ion? So Cl minus ion, 2 Cl minus ion. So what will give Starni? Cl2 plus it is going to give 2 electron. Is it okay?
Sort of, yeah.
Now see the next one at cathode. If you are talking of cathode, so at cathode what is reduction? Reduction means Tarni. Reduction means gain of
Gain.
electron. So 2H plus are there, Tarni. 2 electron you add. So it is going to form what? H2 gas. Yes, yeah, no.
Yes.
So what is being formed at what electrode? So if anyone is asking, that is where the chlorine gas is forming at. Chlorine gas is forming at anode. Hydrogen gas is forming at cathode. Is it okay? Yes, yeah, no.
Yes.
Now go back to the, again you go back where we were studying and what we were studying. Screen is okay. Started taking too much time. Yeah, it's came the same page, no problem. Yes, here you see at anode, the negative chloride ion Cl minus ion are attracted to the positive electrode. They get there, they each lose one electron. The chloride ion are oxidized at they lose electron. The chlorine atom bond together in pair and give off chlorine gas. The half equation are at 2Cl minus and Cl2 plus 2 electron. This can be written as 2Cl. This is also can be written as. So is it okay? At cathode, H plus ion in brine solution formed when water breaks down. So here H plus ion, 2 electron. It is giving H2. Is it okay, Tarni?
Yes.
Now you read this paragraph, please. Read. I am saying you read, please.
The positive hydrogen ions are attracted to the negative electrode. The sodium ions are also attracted to the same electrode. But remember in topic 5.2, you saw what happens when two different ions are attracted to an electrode. It is less reactive element that gets discharged. In this case, hydrogen ions are discharged and sodium ions stay in solution. When the H plus ions get to the negative electrode, they gain one electron. The hydrogen ions are reduced as they gain an electron. The hydrogen atoms bond together in pairs and are given off as hydrogen gas H2. The half equation at the cathode is 2H plus 2 electrons, which gives hydrogen. Plus.
Very good, Tarni. You understood na paragraph by reading, or should I explain?
Yeah, I understood.
Okay. Now see, Tarni, this diagram, you see this diagram. Okay. So this is the sodium, this is the positive anode. Okay. So which gas is coming? Chlorine gas. Here negative cathode is there. Which gas is oxygen, hydrogen gas. So this already I explained you. So remaining solution, what you are going to do? You can test the solution around the cathode negative electrode with indicator. It's so that the solution is alkaline. This is because you can think of the brine containing aqueous ion Na plus and Cl from the salt, H plus and OH minus ion from the water. The Cl ion, NH plus ions are removed during the electrolysis. How? Cl2 here is getting to out and hydrogen. So what is going to be left out? So this leaves at the solution containing Na plus and OH minus ion. That is the solution of sodium hydroxide NaOH. So this is what the okay. Now this you leave no need here. Using chlorine, where you are going to use the chlorine, that is very important one. So here you see that chlorine made when we electrolyze brine is used to kill bacteria, drinking water, also used in the swimming pool. So you can react chlorine with the sodium hydroxide produced in the electrolysis of the brine. This makes the solution bleach. Bleach means they clean the solution. Bleach is very good at killing bacteria. Chlorine is also important in making many other disinfectant as well as the plastic such as PVC, polyvinyl chloride. Now use of hydrogen. Where you are using hydrogen? It is the hydrogen made by electrolysis. Electrolyzing brine is particularly pure. This make it very useful in the food industry. Uh, mar Margarine is made by reacting hydrogen with the vegetable ion. Okay, so this is what the in the hydrogenation process it is being used to convert ghee into vegetable ghee into vegetable oil. Okay, using sodium hydroxide. Sodium hydroxide from the electrolysis of brine is an important alkali in industry. It is used to make soap, paper, as well as bleach. So this is not that much important. Here, please you read the key point, then we will go back to the questions. Okay, read the key point.
When brine is electrolyzed, three products are formed: chlorine gas, hydrogen gas, and sodium hydroxide is solution and alkaline. Chlorine is
Hmm.
used to make bleach, which kills bacteria, and to
Hmm.
make plastics.
Hmm.
Hydrogen is used to make margarine.
Hmm.
Sodium hydroxide is used to make bleach, paper, and soap.
Hmm. So that is what summary question. Summary questions.
Summary questions. What are the three products made when brine is electrolyzed?
Hmm.
Chlorine, hydrogen, and sodium hydroxide.
Second,
They used for I don't to kill bacteria in drinking water.
chlorine is used for bacteria. Hydrogen is
Um,
used to make margarine. Sodium hydroxide is used to make the
margarine,
bleach, paper, and
make
soap.
bleach, paper, and soap.
Question number two.
For electrolysis of brine, write half equation, including statements and yeah,
Hmm.
that one.
At a node, what is Cl minus ion is there? 2 Cl minus ion. So it is
So
Cl2
Cl2
plus
plus
2 electron.
E.
At cathode, 2H plus is there, 2 electron. So it is converting into H2. Is it okay?
Yes.
Question number three.
It is also possible to electrolyze molten sodium electrolytes. Compare the products formed at those electrolyses.
So that is what if you are malting NaCl is there, that we already studied this one, Na plus and Cl minus. So Na it will give only 2 Na it will give, and it is that is Cl2 it will give. We have for molten case we already studied some days back. So there is no problem in this one. Explain any difference. So in the aqueous Tarni, what is there? H2 and O2 also being formed. But in the molten only Na and Cl2 is forming. Yes, yeah, no.
Yes.
This we study. If you forgot, I can't do anything. But this we study. Can I show you? Or you are able to understand?
No, I can.
Electrolysis of knowing?
Yes.
Very good. Up now we are having electroplating. This is electroplating. Then electrolyzing copper sulfate solution. Then this is going to be over. Then it is coming separating mixtures. So two chapter we are studying daily. So next class means that is two chapter will be over. So can we continue or what should I do?
I actually have to go now. So,
Okay. So this is continuous 1 hours you are staying. That is very great things. So we'll be studying in the next class then.
Okay.
Okay. Bye, Tani. Take care.
Bye. Thank you.
Hmm.